Stop me if you have been here before. You write a smart contract, it compiles perfectly, you feel like a genius, and then you deploy it. Transactions get revoked, gas limit throws an error, or worse, it works, but someone actually drains your liquidity pool 2 days later. Welcome back to the channel, guys. This is Rajiv. Today, we aren't just building a tutorial app. Instead, we are going to simulate a disaster so you know how to prevent one in the future. This is going to be a 1 hour masterclass on deep dive into debugging smart contracts on top of the Rootstock blockchain. We are going to take a decentralized prediction market called BTC Outcome, which is currently ridden with bugs, security holes, and logic errors. And we are going to fix it line by line directly inside the Replit. Yes, we are going to use Replit because it's online IDE and it makes the things way easier to manage and install. By the end of this series, you won't just have a working tab, you'll master the art of console.debugging in Solidity, understanding how to trace reverts on the Rootstock Explorer, and even critical vulnerabilities like Re-Entrancy and stale Oracle prices. If you are ready to break things, so we can get started and build them stronger. First, a quick context check. Why we are actually, building this on Rootstock in late 2025. Simply put, why are we actually building it on Rootstock? Simply put, it's the best of both of the worlds. In the Rootstock blockchain, you get the security from the Rootstock blockchain, you get the security of the Bitcoin network. Over 60% of Bitcoin miners merge mine Rootstock, combined with full EVM compatibility. This means we can use the tools we love, Hardhash, Solidity, and MetaMask, but our settlement is secured by Bitcoin. And for our dev environment, we are going to keeping it zero friction. We are using Replit, no local node.js issues, no environment variables nightmare. We are spinning up a hard hat environment in the cloud so you can code along with me instantly. The link to the broken starter repo is in the description. Fork it now because you're going to need it. Or you can follow along and code if you want. Before we start debugging, you need to understand what we think we are building. BTC Outcome is a binary prediction market. The logic is very simple. Users bet our BTC on whether Bitcoin will be above or below our target price. Let's say 150K. It's going to be touching that by a specific timestamp. The contract holds these funds in escrow. And when the time is up, we call an oracle to get the real price, then winner claim the pot, losers lose, of course. Sounds simple, right? Well, the version I have loaded up in a Replit right now is a mess. Well, the version I have loaded up in the example right now is a mess. Here's the bug hunt roadmap for today. First of all, we have a Re-Entrancy vulnerability that allows the user to claim their winnings multiple times, trading the contract. Secondly, our Chainlink Oracle integration is naive. It accepts stale prices, meaning users could, bet on the past. Thirdly, we have a division by zero crash that breaks the contract if nobody bets on the losing side. And last but not the least, we are going to run into some Rootstock specific quirks with guess estimation and block timestamps that will cause our transactions to fail silently. We aren't just going to stare at the code and guess. Instead, we are going to use professional debugging techniques, and we'll be using Hardhat's console.log inside our Solidity contract to print variable states during transaction execution. We'll be using test scripts in Chai or Mocha to reproduce the bugs consistently, and we use the Rootstock testnet explorer in order to inspect failed transaction traces. Okay, that's enough of talking. Let's get our hands dirty and open the Replit.com, and I just head over to the directory, the Replit dashboard of Rootstock DevX. Here we have all the templates which we can, use in order to build tabs on top of Rootstock, from learning boilerplate scaffolds to Rootstock CL. So what we'll do is we'll just head over to the Rootstock hard hat starter kit in here, and we'll just wait so it load. In here we have an example format, basically a start of example for the hard hat, which we can directly fork and use it in our project. So what we'll do is we'll just remix this up. I'll provide the link of this repository in the description. So we are gonna name it as, let's say, Smart Debugging Prediction Prediction Market. So yeah, that's what we're gonna, give it a name. Thereafter, we'll just click on Remix App. And as you can see, it has started to, fork the repository. We'll just wait until the process is completed. Yeah, as you can see, our process is completed. We can, open up our files and preview. Don't have, you just need to head over to faucet.rootstock. And in here, you just need to paste your address and say that I'm not a robot, and you can get some test RPTCs from here. So yeah, that's pretty simple. I'm gonna skip this step because I already have few TRBDCs. So now though our wallet is set, the next thing we gonna do is build our smart contract. So to build a smart contract, as you can see, we have got a structure of files in our starter kit, which do include contracts, deployments, tasks, just everything we need. So it's going to go to the contracts repository. We already have got a few examples of contracts. It is good. Gonna go here and create a new file named as BTC out. So yeah, .sol is basically the Solidity file extension. I'm just gonna hit enter. And right now, we are just gonna chip in the code, which we are using as an example in order to showcase the bugs which we have to resolve in our smart contract. So this is gonna be our example smart contract to showcase all the buggy and other full blocks of codes which we'll correct over the session. So let's just go ahead and first of all have a look at what we have got as a smart contract. Okay, so let's just go ahead, and in the comment section, as you can see, we have listed all the vulnerabilities we are gonna solve and discover in the smart contract, starting from the Re-Entrancy, which is pretty common, and ending with the missing important events. We are gonna solve everything in this smart contract. So this is basically the BTC outcome market. As you know, it's for basic a prediction market. If the price of some tokens such as BTC goes this much at a specific period of time, the answer gets true or false, and the market works in that way. Okay, firstly, the embedded mock price feed or fake oracle. Okay, it's like a toy Bitcoin price we control. It's by default, set at the 140K. We can change it and set the mock price to fake wins or loss. It's just for the example, so it's fine. All right, so in the constructor, we are basically setting a question and but no bounds. Anyone could set a 100-year market, so that's also one of the issue. All right, so now we are declaring few state variables here. First of all, we have a question variable. Thereafter, we have the market and timestamp right here. And then we have, few Boolean variables, which are also set to, public, means everyone can access it basically. We have the variable for market result and the winning outcome. It can be either yes or either no. After that, we have the total liquidity provided and few mappings which basically map the user's address to an unsigned integer for yes position or no position which user has bought. And lastly, we are just specifying total yes shares and total no shares using the unsigned integer. Thereafter, we have, specified few events, not all of them. We are, gonna intentionally miss few events so that we can, make them to, fix the smart contract. Okay, thereafter we have got our constructor, which basically sets question and, but there is something, there are no bounds. Anyone could, set a 100-year market because, we are just declaring the market a duration in days and just using it as the time stamp and setting it. Okay, so thereafter, we have got our buy shares function. This is the main function which actually, writes to the blockchain. This is basically the writable function on top of blockchain, which basically takes two parameters for now is yes and minimum shares expected. In here, we are making this function payable, which is a good thing. And the function which we need to expect and transfer value, we just need to assign it to the payable function. And unless it won't work, thereafter, we are just requiring that the amount we are sending must be greater than 0. Thereafter, we are declaring a temporary variable known as current price. And all right, we are just, specifying the logic here, which is kind of arbitrary and dangerous. We are going to fix it. But, it basically send RBTC for yes and no shares. But the thing is, division by 0, if no liquidity, it's very ignored. And, minimum expected is just a front running bait that's going to cause issues. And the new prices are just like Battle Lemonade stand. So this is pretty dangerous in this function. And, thereafter we don't even have the slippage protection, which could attract the sandwich and attacks. Thereafter, we are just specifying if it is yes, then the shares must be incremented to the shares to mint. And we are just assigning the yes position mapping with the shares to mint. Else we are doing the opposite, the vice versa. So yeah, that's what we are doing. At last, we are just, pushing the total liquidity provided and incrementing it to the message.value. All right, so at last, we are just, emitting out the event which we declared earlier as shares purchased. Okay, now thereafter, we have the dangerous oracle reading function, which is, basically the get current BTC price. In here, we basically call our mock price feed, which we declared earlier, but it barely checks anything, right? It's just giving the stale prices, wrong decimals, and it's just game on for the exploits. So yeah, we are just gonna connect all of this in the session. Okay. So now we have our next function, which is basically the resolve market, which is again an external function. External refers to, we can only call it from the external sources. We can't call it internally. And anyone can call this function. And we have put few request statements in here. First of all, we have the block.timestamps is greater than and equal to the market.timestamp so that it just checks the market is finished or not yet. Thereafter, we have a request statement, which, sees if market is resolved or not. And then the bad thing about here is no owner check, resolve market. Anyone can call this function. We are not checking the owner of the market is calling or not. Thereafter, it uses the price with wrong decimals as we can see here. And, the 1 threshold will definitely flop in here. Right. So yeah, lastly, we are just everything the market resolved event which we declared earlier. After that, we have a claim winning function, which is one of the, main functions of our DApp. Here we have few classic re-entrancy and double claim vulnerability. First of all, we are just checking that the market is resolved or not. Thereafter, we are, creating an uncertainty of winning shares. It basically checks for the winning outcome, whether it's yes position or no position. Now, here's the critical error. There's no reset, like, 1% can, claim the double. 1% can, make the claim twice or thrice. It's possible. And, we are just missing this on purpose. Here, we also, don't have any success check on the transfer, whether the transaction is getting succeeded or not. We are just, we aren't getting that status. These were our main writable function in which our errors were there. Thereafter, we have at last an helper function, which is a view function. View function just, fetches the transactions and data from the blockchain. They just don't write on the blockchain. That's why we don't need to, put fees and gas onto that. So yeah, it's a get market info function, which basically return all of the data which we specified earlier in the same format. Okay, so now we are done on our, buggy piece of smart contract. Now let us just, save the smart contract and try and deploy it for once. Now let's just go to the deploy tab. Here we would need to make a deploy script in order to, deploy our BTC outcome.so. So I'll just go ahead and make a new file named as deploy BTC outcome dot so right here. So now we are just gonna make a deploy script like we have in. I'm just gonna rename it to .ts file because we don't want .source file as they're using the hard hat. So I'll just do .ts. Now we are gonna make a deploy script. Likewise we have in deploy ERC20 and others. Here we can see we just need to import these functions and declare our main function in order to deploy our script. So yeah, let's just do that. Just head over to deploy BTC outcome. Okay, so I'm just gonna throw in the deploy script right here. We have just added a few console logs to help us getting the logged info for the benefit of the audio. So yeah, this is our BTC outcome market. It just fetches it and deploys it into the market variable, and we just wait for the deployment and get the contract address right here. Also, we are just passing the question and duration days as the parameters for our required smart contract as the constructors, basically. Let's just go ahead and first of all in our shell of Replit, let's do. All right, as you can see, we have got a slight error in our smart contract already. So we can just come here in our smart contract. As a stage, we have got the two constructors in our code. So we'll see our first constructor is right here, and our another constructor is right here. So if you find that by yourselves, congratulations. But if not, we are just going to update it. We are just going to get this info and finish this constructor, and we'll just paste the information in here. I'll just format it a little bit. Now we are absolutely good to go. Now let me just open a shell and rerun the command npx hard hat file. So yeah, as you can see, we have few warnings here, but our smart contracts is compiled successfully and we didn't have got any errors. Okay. But we do have some comprehensive and critical bugs in our smart contract, which are not gonna showcased by our Solidity compiler by its own. All right. So the next thing which I want you guys to do is we firstly gonna deploy this smart contract. Thereafter we are gonna let know the nature of these bugs and test those out. So let's just go ahead and say npx hard hat. We need to just run. Gonna go over to the deploy folder and run our deploy btc outcome.ts. I'm just gonna hit run. And it worked pretty straightforward, right? All right, guys. So since the previous deployment was on our local host, it wasn't on the DL rootstock testnet. So this time we are gonna now just deploy it on the testnet. We are just gonna say again that command npx run deploy btc outcome.ts, and now we are gonna specify a network that is our stage testnet that's set up in our hardhat.config.js. So I'll just hit enter and wait. All right, our smart contract is successfully deployed and transaction is confirmed on top of the rootstock testnet. So we can head over to the Explorer of Rootstock. Just go over to explorer.testnet.rootstock.io, and then here we'll chip in the contract address which we just created. And here, as you can see, our contract is minted successfully. Now we'll just head over to our Replit. And, we need to make sure the smart contract is safe. We just copy it. All right, guys. So now, let's start knocking down the smart contract, which we just deployed with some easy exploits first. So we'll start with the access control. That is pretty much a disaster. Anyone can resolve market and decide who wins. That's like letting the audience vote on a sports game after it's over. To demo this, we need some action in this market. Let's try buy a few shares to make it real, and I'll show you two ways to interact. The quick and dirty hard hat console for live poking and a proper test file for more structured debugging of our smart contract. Both the ways are super useful. The console for fast experiments, test for repeatable chaos. Yeah. Now let's just start with the way that's very popular as the NPX hard hat console. And here we will also specify the network we want to work on. But now I just the testnet. So yeah, as you can see, we have got a quick preview of the Node.js. So we can interact it right away from here. Now we will basically attach to the contract and we'll just do it BTC Outcome. Market, that is basically the name of contract. And we will pass in the value of address. And that's all how we get to, make the market and make the contract and the market variable. Thereafter, we will now let's pretend we have liquidity and, buy some of the yes shares in the contract. So I'll just put a statement of await market buy shares, and we will chip in the parameters that we give in the function. First of all, we want to buy true shares, that is CS. And at last, we will, give the value we need to pass. Either suppose, pass the value to be 0.0005 as we are, working in, as we are dealing with the testnet. Yeah, I'll just close the parentheses and brackets. All right, you see that the transaction mined in 30 seconds thanks to Rootstock. If it fails with division by 0, that's our next bug. For now, assume it works or skip to the exploit. Now, let's go on and, set the mock price high so yes wins. So I'll just do await market dot price. We will, set it somewhere like suppose 160K. Yeah, and that's it. And 160K is basically above our threshold, that is 150K. I'll just enter. And as you can see, our transaction has been successfully executed, right? So yeah, that's the beauty of, NPX hard hat console. We can easily access all the functions right away in our terminal or shell. So I'll also, now hit the resolve market function from the same console, even if I'm not the owner, right? So I'll just do await market dot resolve market. You'll see what happens. Boom, the market has been resolved. And we see that, yes wins. But wait, anyone can do this. Think of it as a bad guy front running the real and dying. Wrong winner logged forever. And pools are suddenly stolen. Now that is the error which we need to correct. Alright, before that, we now will look into the next type of, testing in the hard hat environment. It's basically for repeatable automated exploits. All right, so in this way, we can write once and run anytime. It's a very strategic and functional way of, testing out a smart contract. So let's just go ahead and in our test folder, create a new file. No, as suppose BTC Outcome test. Now in here, first of all, we are gonna, import few things. So let's import spec. After we will import ethers from the hard hat. Thereafter, we'll write down our first test. We are gonna start up with a describe statement, and in here we'll write EDC exploits as you're exploiting our contract. sign a function and put curly braces in there. Now we'll say a variable market, which will be type of any, and thereafter we will declare that before this asynchronous function, inside of this function, we're gonna cast const BTC outcome market is will be equals to await does not get factory contract. That's what basically we do. Thereafter, we will say that market is equals to await Bitcoin BTC outcome market dot deploy with the test market, right? This will basically be our quick test. That's why we are, providing the zeroth here. Thereafter, we'll just say await market dot wait for deployment. Here, first of all, we are, deploying the contact. Now, thereafter, once specifying the functionality which we want to follow, we will use it statement in order to verify the things. We are just saying that anyone can resolve the market and a sales function will curly braces in here. Thereafter, we will say that await market dot. First of all, we are gonna buy the shares. Let's write 0 in here. First of all, we will provide true in here, followed by 0. And lastly, we'll pass in the value that we are going to parse. In this case, we say a small value as we are in testnet to this. And after that, we will basically create one more await statement for market to be resolved. We don't need to provide the parameter as to here. We just want the market to be resolved. And we close it. And then right here, you open up a statement of await market dot set mock price. And, we'll just pass in the 150K here. All right. So now we would need to, specify that market is resolved. So we'll just call market.resolve market. Thereafter, we need to, check whether the market is resolved or not. So we'll just say const resolved is equals to await market dot is resolved. So yeah, that's what we are going to do. And at last, as we are testing out, so we would, use the expect statement, give it a parameter resolved and state that it should be true. That's how our test case will pass. So yeah, this is how we even call the functions in the NTXR console. And in a similar way, we just use some statements of test and specified or test in order to get the info from the contract. Right. That's pretty cool. So let's get forward. All right, so now just head back to the shell, and here we just need to specify npx hard test and the test file which we have wrote, that is BTC outcome test.ts. Awesome. See, test passes, but that's bad, proves the exploit. For a real non-owner test, we can use signers, one like, attacker is equals to signer, and, later on await the market dot connect and, push on the attacker to resolve the market. Now, the impact of this exploit is that, pool logged wrong, and fixed time, it can add the access control. As we have seen this exploit, now we would like to correct this exploit. Now anyone can access a market right now, like anyone can call the resolve function. So we would need to correct that in our smart contract, right? So let's just go. And in here, I want you guys to, import from the OpenZappelin library. All right, OpenZappelin is the most secure library, and with utmost tools to integrate in the smart contract, we are just importing the ownable in order to make our own smart contract secure so that our functions keep safe. Now we would also need to update the contract. We'll just say BTC outcome market is ownable, and we'll just say owner will be close to the message dot sender, the one who deployed the contract, right? Yeah, that's what we need to do. The next thing is now we need to implement the ownable functionality on the function which we are referring to. So in this case, the resolve market function. So in this function, we will just include that this function is only callable by the owner. Let me just compile this again. We'll just go to the shell, and here we'll say get start hat compile. We just need to, put the enable into the curly braces. That's all. We should be good to go. Yeah, it's compiled successfully. All right, now, though we have, deployed our contract with ownable functionality, let's now add a test case in order to check that. So in this test case, we are just specifying that, no can resolve or not. If it succeeded, it's a bug. If not, we have resolved the bug successfully, right? So I'll just go into the shell and I will just run again our test mpx hard hat but in the test file, that's BTC Outcome. So yeah, as you can see, our test second one is failing because it is giving us the enable unauthorization error, which is we are trying to, claim the resolve function from another account. That is unacceptable, right? So that's why we have secured this by the enable. Now let's move forward and, come back to our smart contract and correct some more errors in here. So the thing is, right now, there's no check for stale data. So if the price is old, it usually still gets used. In console, now let's fake a low price. Now let us, reopen our console. And in this, first of all, let us, set the mock price of BTC to something like 1K to test it out. Mock price, I'll just put in the parameter that will be 1 All right, as you can see, our transaction has successfully gone through. And now when we will be, resolving the market, let me just call the resolve market function, market dot resolve market. And as you can see in here, this wrong outcome, there is no wins, even though we wanted yes earlier, but there's an exploit. Someone could, delay the resolution until the price feed is stale. That is, the force of a bad result. Now think of it as a real oracle, which will, wait 2 hours during an outage, old price used, and pools will be stolen, right? Now, in order to, fix this issue, we would need to add staleness and round checks and get current BTC price function. So let's add that to our smart contract. And right here in the get current BTC price function, we would need to add a couple more, requirement statements. So we'll just first of all, fire updated at should be greater than equal to the block dot timestamps subtracted 3600, and you say that it's a stale data. Another thing which we need to do is provide one more require statement in order to chip in the incomplete round functionality. So we'll say that we are going to use the require function and we will use the answered in round is equals to the round ID. Then it should throw out that it is an incomplete round. So the decimal mismatch is another sneaky one. Our mock currently, returns 8 decimal price like real chain link, but our BTC uses 18 decimals. Threshold is written as 150K multiplied by 1E8. That is your wrong scaling. For the demo, we can set the price exactly 150K. Your resolve might resolve wrong because of scaling error. Okay, so in here we would also need to correct the price here. So we will just multiply this with 1E10. That will correct with the rootstocks RBTC. And then we will also update the threshold in the resolve market. We will say that winning outcome is equals to 150K multiplied by 1E8. That will do the job. Now, before it was the very wrong result, and after these changes, we have got it to be the perfect. Now we are basically safe from the fake prices. Maybe, but wait till you see the next one, right? We are about to drain the entire pool in one transaction. Alright, so now the thing is, we have locked down access control and tamped the faked oracle, but the contract is still hiding its nastiest secret. That's the classic re-entrancy error. This is a bug that, has eaten hundreds of millions of dollars in real life. And guess what? Claim links function is the perfect victim. Why? Because it basically sends money before updating any status. That means if I make a sneaky contract that calls claim winnings again inside its receive function, I can keep draining the pool until it's all empty. Like, it's a broken vending machine and I'm just withdrawing snacks after snacks into it. So yeah. For proving this, we would, create a new smart contract in order to test it. So let me just go ahead and in our contracts directory, create a new file known as, let's say, Re-Entrancy attacker dot. And in here, we need a pretty basic smart contract in order to just call the function of our BTC outcome market, the claim winning function. So we'll start by SPDX license identifier as MIT, and we'll specify the version of solid. Thereafter, we will define the interface for our BTC outcome. We will name it as IBTC outcome market, and in here, we will just put the claim winnings function with its type and the buy shares function with the parameter of yes and minimum share expected. This is also an external function, and it is also a payable function by term. Yeah. So after that, we will declare the contract, that is the Re-Entrancy attacker, and in this contract, first of all, we are going to declare the IBTC outcome marketplace and name it as the market. Thereafter, we will declare the unsigned integer of attack count, let's say. After that, we will just declare a constructor that puts the address of the market. We will also define the market is equals to receive market. Now we will specify a receive function in the smart contract that will be receiving the amount to make it payable. And if attack count is let's say greater than 5 for now, then we would increment the attack count first of all. Thereafter, it should call the function market dot claim winning or our smart contract, right? So after this, we are gonna make another function that is going to be attack, and this will also be the payable function. What it will do is it will just call the buy shares function on our market. We'll provide the parameters, first of all true, 0, and then we will pass in the value, message dot value. After that, we will again call the market dot claim winnings function, and it will basically start the drainage for our smart contract. So yeah, this is the Re-Entrancy attacker smart contract, which we are going to use to get the bug in our smart contract. For deploying this smart contract, we would also need to make a deploy script. So we will just make one deployed in Entrancy, let's say .ts. Yeah. For this, we are going to work smartly, so I'll just go and copy this script and just paste it in there. So while we are importing the ethers and getting the signer, in here we will need to change this. We will name it to the attacker, let's say, and get the name of our contract, that is the Re-Entrancy attacker. Make it correct. Yeah, and change this too. And we will get rid of the parameters. However, we would need to, pass in the address of the market. So we will just ship in this address and change the variable name as well as attacker deployed or doing deployment and get the address right here apply. Alright, so we are good to go. And now I'll just run this script in our shell, Re-Entrancy dot. Alright, so we will just correct this bug. We have successfully deployed our, attacker, Re-Entrancy attacker contract. We have got the address of it. Now what we'll do is, and particularly our new shell again. Alright, so first of all, we will just open the hardhat console. Alright, we'll just run this and now call the function on this contract. Await attacker dot attack, and we will just pass in some value, the ethos dot, and we will suppose say 0.1 for instance, and close this up. Oh no, so the pool is gone in one transaction, attacker will be able to attack in the whole pool. Alright guys, so now we have moved forward to the fixed time, which is going to be the super satisfying part. So first of all, we would need to install the Entrancy guard. If we don't already have that from OpenZepplin's contract, we will import the Re-Entrancy guard, OpenZeppelin library, and we will specify it in the contract header and make it dependable to the Re-Entrancy guard, just like that. Now we will head over to the buy shares and claim winning functions of ours. Now we will, specify a modifier in this function. In this case, it's gonna be non-reentrant. Also, I'll do same for the claim winnings function, just like that. And in claim winnings, it's very critical for us to, change the order. First of all, we want to, place the market check. Okay. Thereafter, we need to have the winning shares check. And thereafter, we need to have the total winning shares. And thereafter, we are gonna take the payout. And lastly, in the transaction part, we would, need to specify a require statement, which will be we need to check if the transaction has got through and succeeded or not. It's a very crucial part because if the transaction has failed, we would never know and it would never log if we don't specify it. Okay, so now our functions are secure and we have also got and also we will set earliest positions of the message dot sender to 0 as we were missing it on purpose. Alright guys, so for now we can compile our contracts again. So as you can see, this file is not found, so we can just import it. Alright, we'll just go back contract folder. In this file, we will just change the directory from security to Euros. Cause in the latest version, the open substance re-intrinsic art location has been shifted, so we'll just update. And we'll just again hit npx hard compile. And as you can see, our contract has been successfully compiled. So we can see that our contract does not have any errors and it's pretty good to go. Now our pool is safe, no more, money glitch. This is why the checks effects interaction pattern is pretty much and amazing. We are almost coming into the production zone, but still some ugly rounding and gas surprises are left. We are just, gonna go and do the final cleaning up. Now the contract looked up, but let's make it beautiful and user friendly at the same time. The first problem here is, we are just rounding all of the losses. Small winners gets 0 because of integer division. Now we need to, fix it. But how? So we will change the method of the calculation of payout that we are doing. We'll correct it. We'll send remaining dust that is left over to the owner. So in here, in our claim winning function, we will add a variable known as dust. Okay, this will basically, transfer the balance of this address. First of all, it will check whether the address has some balance or not. If there is some dust which is greater than 0, then it will basically be payable to owner and it will transfer the dust itself. That's pretty cool, right? Format it a little bit and we are good to go. Now the second thing which comes here is creator does deserve something, okay? As the one who is, creating the market is putting some effort. So it's our duty to, give him some royalty or some fees on the buys. So in the buy shares function, right here, we are gonna, after this message dot value is greater than 0, we're gonna add an unsigned integer of fees. And it will forsake the value of fees that will be going to be multiplied by message dot value to fee underscore BTS. And later on, we'll just cut it off by division of 10,000. Yeah. Now, if the fee is greater than 0, it will be payable to the owner itself, and we will just transfer the fee as we do, right? So yeah, and we will also update the net amount to message.value, subtract it with the fees, right? That's what we are gonna do, and at last we are gonna increment the total liquidity provided with the net amount. So yeah, in this manner, we are providing the fees to the creator of this prediction market, right? That's pretty great. Now, thirdly, we have the rootstock block type quirk. In rootstock, blocks, takes 20 to 40 seconds, not exactly 30 seconds. We need to, add a tolerance window for this resolution, right? So now in the, resolve market function, which is right here, we will given this require statement, which basically states that the block is taking some time and it's just if it's not in that time, it will throw that it's outside the resolution window for now. Yeah, after that we have the slippage protection, which we talked about earlier. So in here, as we can see, we didn't have provided any slippage protection, but we do have an hint, so we'll just unwrap this hint and put this require statement. What it basically does is it checks that the share to mint is greater than and equal to the minimum shares expected, and which in that case throws the slippage too high. That is what we need to correct all of the errors in the smart contract. Now it's end-to-end completed. We can just go here and again put an npx hardhat compile and check out for more errors. We just correct these errors. So we forgot to declare the fee BPS, and also we have some machine dust. So we'll just go ahead and smart contract at like 98 and 198. So in here we will declare a constant right here, or we will go conventionally and declare a constant event public constant feed BPS, and for now we are going to set it to suppose 50. Thereafter at line 198 we declared the dust. Okay, so in here we will just get rid of the const and just define an event, because that's conventional and that was faulty. We cannot use const and local variable in Solidity, right? After resolving these, we can come back and just run npx hardhat compile again. And as you can see, we have got one warning, but our Solidity file has been compiled successfully. Now we can run again the deploy command dx deploy script, run deploy slash BTC Outcome.net. All right, guys. So finally, we did it from the buggy code mess that would get drained in seconds. We have built a solid, safe-ish prediction market on top of the Rootstock blockchain. Now you can see our contract has successfully deployed to this address, and everything works and compiles. You can write out more tests by yourself. You can take this repository and fork it and do experiments by yourselves, contest cases, write new tasks, new contracts. You can use these contracts as the primitive ones and build on top of them. You can do anything basically, right? So yeah, so biggest lessons we learned so far were, never send money before, updating the state. That was our Re-Entrancy 101. Thereafter we have the validate oracles like crazy. We have stale, decimals, and rounds. We have seen everything, right? Thereafter we had the double every public function like ownable. We got to know about modifiers. We used them, and thereafter we wrote test edge cases early, which was zero liquidity, tiny bets, and all data. Thereafter, Rootstock is pretty amazing, right? It's fast, cheap, Bitcoin secured, but still needs Ethereum level code. You now have the debugging superpowers most devs learned the hard way. It's a little bit of challenge, you can fork the repo and experiment with it. You can deploy your own market on a testnet, drop the address, or a funny exploit screenshot in the comments if you like. Thanks for hanging out for the full hour. You're awesome. Keep building, stay safe, and remember, the best code is code that survives curious hackers like us today. So, see you next time. Signing off.